So in our last lecture module, we introduced this idea, this way of characterizing inferences as psychological processes that take information that is explicit and available to them and transform that information to generate new explicit and available information. And we said we want to clarify exactly what we mean by explicit and available to help us better understand that notion of inference that we're operating with. And so one way that I do that in the textbook is to introduce this sort of metaphor of two chalkboards. So we can imagine that I've got a shop, and in my shop, I've got a small chalkboard up front where I keep information that I need when I'm working up front while watching my store. In the back, I've got a big chalkboard where I record all of the important information that I need to run my shop. Now, when I'm up front and I need a bit of information and it's not on the chalkboard, then that information is the equivalent of unavailable to me. It's there somewhere, but it's not available to me as I'm standing in that front room. If I need that information, I have to take that small chalkboard and go back to the big chalkboard in the back and write that information down. Once I have that information on my small chalkboard, then when I return to the front, I have that information. It is available to me. So when we talk about information being available, that's the notion that we're thinking of. A psychological process has access to that information. So for instance, our visual system has access to the surface reflectance values that are collected by the photosensitive cells at the back of our eye. It has access to that. Lots of other psychological processes in my brain have no access to that. That information is available to visual processing. It is unavailable to, for instance, my long-term working memory processes. What about that notion of explicit and implicit information? Well, information is explicit when it's encoded in a way that allows me to understand or use it to solve a problem or make an information transformation. So a process has information that's explicitly available to it if that information is encoded in a way that it can take advantage of for the purposes at hand. And to illustrate this distinction between implicit and explicit, I use in this chalkboard, for example, and in the textbook, these two different ways of representing the mathematical constant pi. So here we have the Greek letter. It just represents the constant that corresponds to pi, but it doesn't explicitly represent its actual value. So using that constant, I can write out formulas that explicitly represent the relationship between, for instance, the area of a circle and its radius. So by representing pi using the Greek letter, I can represent it as a constant so that I can express or utilize relationships between, for instance, area and radius in circles. However, that constant representation, that doesn't make the value of pi explicit. And so if I need to calculate the actual area of a circle, say I need to figure out how much cloth I'd need in order to cover that circle. The decimal approximation of pi is what I need. It explicitly represents a value for pi that I can use in my calculations. So the constant pi doesn't explicitly represent the value. It just represents a constant. The decimal approximation of pi explicitly represents a value, and in doing so, it actually doesn't represent the constant itself, since that value is only an approximation. So explicit information is information that's represented in a way that that information can be utilized for the purposes of some inferential transformation. A bit of information is implicit if it's not encoded in that way. If it is encoded, for instance, as the value of pi is encoded here by using our constant symbol of the Greek letter pi. And when we think about inferences in this way, it's important, and this is why I use Sigmund Freud as our spokesperson for this part of the lecture. It's important for us to realize that these psychological processes aren't just the ones that we're consciously aware of or deliberately using. When we're walking on the quad, we might see a friend of ours from critical thinking. Now, we recognize this person because our visual system made several unconscious inferences based on information that was gathered at the back of our eye about the surface reflectance of the visual scene, and it made those inferences in a manner that was completely unconscious. Only the final deliverance of those inferences ever makes it even potentially into our conscious awareness. So when we recognize our friend consciously, that is the end point of a long series of unconscious inferences. Now, we may recall that we have a test next week, and we might make some semi-conscious inferences. So we might think, oh, I got a test. Oh, maybe I should study with my friend here. And we might walk over. In doing so, we may be aware of certain parts of the inferences that we're making. For instance, the inferences that guide our walking towards that person. We may walk around a bench. We may adjust our gait to go up and down some stairs. We may do all of these things, most of which probably don't actually make it into consciousness, though some things do. We intend to go to our friend. We see the stairs. These things might make it into consciousness, but not the entire inferential process, only bits and pieces of it as we go through. And I refer to those as semi-conscious inferences. Now, when we study, we may use one of the techniques that we're going to learn this term. And so you may use the truth table method to evaluate the validity of some particular deductive argument. And in this instance, you'll be consciously performing an inference. What you do is systematically performed using your working memory, and hence is a conscious inference. Now, it's really important for us to realize that the psychological processes that perform our inferences aren't just limited to the ones that we're consciously aware of. Now, we can sort of think about our inference capacities as the tip of an iceberg. The conscious part of our inference capacities, the things that we do consciously, is just this small part of that iceberg that sticks up above the surface. Below the surface, there are all these inferences, all this information processing going on that never actually makes it into consciousness. And this will turn out to be particularly important as we continue on looking at inferences, and particularly when we start talking about the general categories or types of inference strategies that human beings typically can call upon in solving problems. So inferences can occur at many levels. They can occur unconsciously, as with visual recognition. They can occur semi-consciously, as when we react to a situation, only parts of which we're sort of explicitly aware of. And they can occur when we're explicitly and consciously trying to solve a problem using our working memory. These inferences are made by different parts of our brain, different brain systems. Each of those systems, however, has access to information. That information is available to that system, and it's available in a format that that system can use to make the inference, so it is explicit information for that system. But that doesn't mean that it's available or explicit to any other psychological processes, for instance, our conscious awareness. So when we talk about available and explicit information, we don't just mean information that we're consciously aware of. Information is available just because it's accessible to a psychological process, and it's unavailable if that psychological process doesn't have access to that information. It's explicit if it's encoded in a usable form so that that psychological process can take advantage of that information. It's implicit if it's not encoded in that way, or if it's not explicitly encoded at all. We'll pick these ideas up in our next lecture module.